I'm going to be giving a talk on looking at sort of nutrition of the contemporary dairy cow. Quite a big area to cover in sort of 20-25 minutes or so. But the main areas that I'm hoping to cover are, first of all, looking at sort of forward-looking in terms of what's likely to happen to feed prices and what factors are influencing that and what pressures there are in terms of feed prices for dairy cows. Focusing a little bit on concentrate feeding and potential concentrates and supply and cost. Then moving on very briefly to look at protein nutrition, something on alternative forages and grassland, particularly for higher yielding cows, and then finally finishing off on winter mineral feeding. So quite a bit to cover. Just as a general bit of background, I think it's useful to bear in mind that whilst we speak about 10,000 dairy farmers in the UK, or in England and Wales, there are approximately 122 million dairy farmers or people who derive an income from milk throughout the world. And in total there's about 363 million dairy cows in buffalo, around about 260 million dairy cows and the remainder being buffalo. And if we look at the increase in milk yield, and this is milk yield from dairy cows, we can see that there's been a pretty unrelenting increase in milk yield of around about 10 billion litres per year, which in context the UK produces around about 14 billion litres, something like that. If you divide 363 by 122, then you come to an average herd size of about 3 cows, so that's what world milk production is. And the average milk yield is around about 2,100 kilograms. Quite a bit different from what we generally envisage to be dairy production, both in the US, the UK and New Zealand. But to put this in context, for countries that have got a modest milk yield of 2,100 kilograms, that's around about 6 kilograms per cow per day. To increase their milk yield to 8 kilograms per cow per day, will require about an extra 10% of added feed input. If you compare that with somewhere like the United States with a much higher milk yield, then for them to get an extra third milk yield would require somewhere in the region of 25% extra feed. So a lot of the competitive countries to us in the UK may have modest milk yields just now, but they're actually quite competitive if they're going to go out into the world market to purchase feed. So the UK here, although we are relatively small, we're still the 9th largest milk producer within the world. But you can see that nobody's really influencing it. The United States is quite a bit larger, but nobody really having a major influence on that. Most of the milk is consumed in the country where it's produced. This is some data from the IFCN, who are projecting what's likely to happen in the future, and they're predicting around about 1,000 million tonnes of ECM, that's energy corrected milk yield, by about the year 2023. That's an extra 29% or 225 million tonnes of milk. And this they anticipate being driven by a relatively modest increase in terms of per capita consumption and also an increase in world population. And to meet that, they are forecasting an extra 47 million dairy animals. And to put that in context, the UK's got somewhere in the region of 1.8 million, so around about 25 times the size of the UK dairy industry. And also a relatively modest but nevertheless significant increase in milk yield, around about 14% as well. So in terms of future demand for feed, there's going to be a lot more dairy cows wanted to consume a lot more feed. Not only do we need to produce this extra feed this extra milk as we move forward, we need to produce it using less human usable feeds, and I'll explain what I mean by that in a minute. We should be using less land and water because of its requirements for other areas, using less energy and fossil fuels, and having a lower impact on the environment. We also need to produce our milk to higher welfare standards and using less inputs such as pesticides, antibiotics, drugs, etc. And we should also produce the milk to higher quality, and that includes microbiological quality, safety, and we're aware of issues in China recently, and aspects of nutrition, which is a little bit outside what I'm the sort of remit of the talk this evening, but nevertheless producing milk as a product which is going to improve human health is an area of considerable interest as well. If we move on and look at sort of trends in feed costs and milk price, again this is from the IFCN, and this is looking here at world trends in milk price, and this is US dollars per 100 kilograms, so putting it into a constant cost. And also the green line here represents feed costs, and this is for standard concentrate that they use to monitor changes in world feed prices. And we can see that there's been considerable fluctuation in world milk price over the last 10 years or so, and we're certainly experiencing that at the current time. And equally in terms of feed price, there's been fluctuation as well, although the longer term trend certainly in feed has been upward. If we look at the ratio between the two, so that's the feed price to the milk price, then it comes out to be round about 1.5. In other words, if concentrate costs is 20 pence per kilogram, that's 200 pounds per tonne, then milk price needs to be somewhere around about 30 pence per litre. That's where the 1.5 comes from. And again, we can see that there have been periods of considerable fluctuation, major changes. So here we have a period of time where milk price has been very favourable in terms of feed price, and then we've got other times where it has been the reverse. And at the current point in time, we're probably around about this kind of area as well. So we're living in a very volatile time, both in terms of milk price and feed prices, but there's opportunity at certain times to be able to maximise that advantage, and at other times to perhaps minimise it. So being adaptable is going to be important. If we look at aspects of concentrate supplementation, then we generally consider two major systems, or perhaps two extreme systems of milk production: the high output, more North American style, and the grazing-based New Zealand style. And we have both types of system in the UK, although most farmers tend to fall somewhere in between the two. And the increase in milk yield, both in terms of Western countries and in terms of the rest of the world, Asia Pacific, for example, is going to be based on purchased concentrates. Most of the increase in milk production from countries that want to increase yield and output are going to be from countries that are generally not grazing based. So they're going to be based on forages and then having to purchase feeds. A lot of the feeds that we currently assume are going to be fed to dairy cows, there's going to be greater competition. There are also issues regarding feeding level and rate of degradability of starch. Most of our increase in milk yield has been through feeding extra concentrates and often starch-based. I'll mention that a little bit later. And also competition for human food and fuel use. So this is some calculations that Mike Wilkinson did at the University of Nottingham, and he looked at the typical composition of UK concentrates. And you can see that somewhere in the region of about 36% of the concentrates that we currently feed, or the ingredients that we currently feed, could be regarded as being human edible. In other words, they could be used for human consumption. And that's obviously going to be a greater competition as we move forward. However, it's not all particular doom and gloom. If you consider, for example, current protein productions, this is from poultry meat, milk and beef, and this is protein output per kilogram of, protein input per kilogram of product, then it takes somewhere in the region of about 3 kilograms of dietary protein to produce 1 kilogram of poultry meat protein. Higher for milk, here about twice as high, and beef even higher. If, however, we consider the human edible protein input required to produce each kilogram, then we can see that milk comes out to be considerably more favourable. So poultry comes down to about 2.1, and milk becomes lower at less than 1. And that is really utilising the ability of the dairy cow and its rumen to produce protein and not having to feed human edible protein, and that may become more important as we move forward as well. And of course that means a greater reliance on byproduct feeds and improving the nutritional value of byproduct feeds. But we should also be conscious that whilst in theory this may sound quite good, byproduct feeds very often shadow that of cereals, and we're all too aware of how certain byproducts such as sugar beet pulp will increase and decrease in price, not related to the cost of sugar beet, but related to the cost of wheat. So whilst we may consider this to be advantageous, the inputs will inevitably be driven by market forces. In using more byproduct feeds, I'm very briefly going to touch on them. They generally tend to be higher in fibre, they generally tend to be more lignified, and often we concentrate anti-nutritional factors from these byproduct feeds as well. But they needn't all be particularly low quality. And we are likely to have more of these. For example, at the current point in time, approximately 40% of the maize or corn production used in the United States doesn't go for animal production, doesn't go for human consumption, it goes for bioethanol production. So this increased demand for food also includes fuels as well. But it's not all negative. The byproduct feeds such as distillers' grains are often high, but they generally can be variable quality as well. So for example, we're aware of distillers' grains for a long period of time in the UK, high protein content, quite a bit of degradable protein, quite a high oil content, and a high but generally variable ME. And if we look at studies, for example, in the United States where they had variable levels of inclusion of distillers' grains, we can see there's no reason why we should expect a reduction in milk yield or intake unless we go for very high inclusion rates. But inevitably including byproducts does tend to have some negative impacts, and feeding distillers' grains does tend to reduce milk fat levels, particularly if we have higher fat levels to begin with. So that's something that we need to be conscious of and consider when we formulate rations, how to avoid milk fat depression. An accurate feed evaluation is going to be important in relation to that. Moving on very quickly to the next topic, which is protein nutrition. And as we saw for the general trend for feed prices, soybean meal has also been considerably variable in its cost, and we've witnessed a threefold increase over the last period of time, and that's obviously a major input. And the other issue relating to protein is that dairy cows are generally not particularly efficient at capturing dietary N. So if we consider how much nitrogen or protein that we provide to our cows, that only about 20 to 35% of that is captured in the milk. The rest comes out mainly in the urine, but also in the fecal material as well. But we do know that the efficiency of that nitrogen capture declines to the dietary protein level. So here we can see, and we're focusing here on the blue line, and we can see that as we decrease dietary protein level, we get an increase in the efficiency. So going up from about 25% at a high dietary protein level up to over 35%. And the major driver behind that is the reduction in urinary nitrogen excretion. So we know that reducing dietary protein levels will also improve nitrogen efficiency, and in terms of areas such as NBZs, then that's obviously a good thing. So a double bonus from reducing from reducing dietary protein inputs. So why don't we do it now? Well, the major problem is that the general response is that as dietary protein is reduced, so is milk yield. So we can see here that reducing from about 18% to 14% can reduce milk yield, and that's not something we particularly want. That reduction in milk output more than offsets the dietary protein cost. So what we want to do, and what our research is aiming at, both work that we're doing here and at other institutes, is to try and maintain this milk yield up at this level here whilst reducing dietary protein levels. And we know from a review that we did of the literature on behalf of DairyCo that as long as we formulate diets adequately and balance rumen requirements with animal requirements, then we should be able to get down to around about 160 60 grams per kilogram dry matter, or 16%, without any major negative effects in milk yield. But it is really getting much below that 16%, 160 grams per kilogram dry matter, is where we have most greatest challenge. And we know that early lactation appears to be the most sensitive period, and this is some work that was done at Hillsborough in Northern Ireland. And here they fed throughout the whole of lactation, so this is a week of lactation along the axis here, and then we have got milk yield going up here, and the general typical milk response curve, and this is feeding just over 17%, 173 grams per kilogram dry matter throughout the whole of the lactation period. They also fed a lower level as well, and they got this reduction in milk yield here. So 14%, 144 for the first and second half of lactation. But what they also found was that when they supplied 17% for the first half and then 14% for the second half, that they were able to maintain milk yield. So we certainly know that particularly in later lactation, we should be able to drive these dietary protein levels down and improve efficiency and hopefully reduce feed costs as well. But we know in terms of protein that it isn't just crude protein that we're interested in. We've got to consider the rumen requirements and the animals requirements. And if we look at the balance between these two, so this is now looking at metabolizable protein requirements. So this is what the cow actually absorbs, and this is milk yield along the x-axis here. We can see that increasing milk yield increases the cow's metabolizable protein requirements in a pretty much a straight line response. The rumen microbes are able to supply a large quantity of this metabolizable protein, but you can see that as we get up to higher milk levels, that the difference between the two increases. And we need to supply more bypass protein. And that can be a little bit of a problem because most of the basal forages that we provide dairy cows tend to be highly degradable. They tend to be high in rumen degradable protein. So if we consider grass silage or lucerne, sometimes called alfalfa, which I'll be coming back to a little bit later, then we can see that over 80% is rumen available, and only about 20 to 17% is bypass. If we compare that with soybean meal, it's considerably higher. So we need to be considering two things. First of all, can we increase this microbial protein production? And that's something that we're currently doing in a study with Nottingham University, funded by DairyCo, which we hope to have the results soon, where we've been looking at strategies to feed lower levels of protein and try and get more microbial protein synthesis. And the second option is to try and increase this bypass, particularly in relation to basal forages. And that's something that we've been doing. We're just about to start some studies trying to look at forages, and there are a variety of different ways of doing that. One way is to breed plants that have got more bypass protein. The second is to look at compounds that will reduce the rumen availability. And we're focusing on tannins, and the different types of tannins. But we have harvested some forage peas, and we know that forage peas that are coloured flour are higher in condensed tannins, and condensed tannins bind with protein within the rumen and prevent the microbes from attacking it, so they are reducing the rumen degradable protein. But also importantly, when they get to the true stomach and the acid conditions, the tannins should release the protein and provide a greater metabolizable or bypass protein supply. So that's what we're about to start. Again, this is a study funded by DairyCo, and we should have the results by next winter. The next area I want to very briefly move on to is alternative forages, and we've been focusing as part of the research partnership with DairyCo along with Reading University and SRUC in Scotland. We've been looking at focusing on lucerne, and we particularly were interested in lucerne because it's very widely grown in the rest of Europe, and particularly in North America. It's you know, the common forage that's used there, certainly the most common legume. Its advantages are that it is a legume, so it fixes nitrogen and therefore potentially reduces nitrogen input costs. And it's also high in protein, so somewhere around about 20% protein, 200 grams per kilogram dry matter. It's also more drought tolerant. It's a very large taproot, and that may be advantageous, particularly in dry summers when grass doesn't grow well. Lucerne should. And it also has a more functional fiber content. Lucerne is quite high in fiber. Well, it's similar to grass silage, but what it's quite high in is indigestible fiber. But the fiber that is digestible is broken down very rapidly. So you tend to get a rapid outflow rate with Lucerne, and that increases intake. And it is thought that the indigestible fiber may improve rumen conditions, particularly relevant for higher yielding cows. So we've completed a study last winter. We were looking at Lucerne. And in this area we wanted to compare it with the standard grass maize silage. So these cows were fed around about 55% forage and 45% concentrates. And the control ration was grass maize silage, so 40% grass, 60% maize on a dry matter basis. We then replaced half of the grass with Lucerne. That made it 20-20-60. And then we replaced all of the grass with Lucerne, so that made 40-60. So that gave a direct comparison between this treatment and this treatment. And then we pushed Lucerne levels up a bit higher, up to 60%, which gave us our fourth treatment. When we look at the animal performance, then all treatments performed well. They all produced over 40 kilograms of milk over our study period. Dry matter intakes were also high. We didn't get any increase in dry matter intake from feeding the Lucerne, although we did get a decrease at the highest level. Milk yield was not significantly affected, so similar milk yield. And perhaps a little bit surprisingly, we didn't get any effects on milk fat. We did consider perhaps we may have an improvement in milk fat with Lucerne, but we didn't. Live weight change was positive for all treatments, but it did tend to come down lowest in the L60. So this one here looked to perhaps be one of the better treatments. But certainly we can replace grass silage with Lucerne and have no negative effect on milk yield and a comparable performance. So what advantages are there from Lucerne? Well, in feeding the Lucerne, because of its higher protein content, we were able to reduce feed costs. So this is some of the feeds that we included. And you can see that we reduced the soya by about 0.6 kilograms per day. We took the feed grade urea out. We then had to increase some of the wheat and some of the sugar beet pulp to make up the difference. And in total, we calculated that saved around about 23 pence per day, or 23 pounds for 100 cows. And that's assuming that there were no difference in forage costs. But as I said, there may be benefits in terms of fertilizer costs, but it'll be very much dependent on the crop yield. Very briefly looking at grazing high-yielding cows, which is another area that we've had interest in, and there's a lot of farmer and public interest in continuous housing of dairy cows. And we've had an ongoing series of projects, again funded by DairyCo, looking at investigating cow preference to be at pasture or housed, and that's a little bit outside the remit of tonight's talk. But we also have a project, again with SRUC, looking at different strategies to try and increase grass intake, and we're focusing particularly on graze grass. And we completed a study where we were looking at a variety of different treatments, but we had some cows that were continuously housed. So this is our feeding system at Harper Adams when cows are inside. So these are our electronic feed bins where the cows, we can feed them different diets and we can record their intake. We then had some cows grazing during the daytime, so this is a cow here grazing. And some of the cows who were grazing had access to the grass, but they also had access, for the purposes of this study, to the total mixed rations, the same total mixed ration as they had inside. So we ended up having 3 treatments. So in this aspect here, we had continuously housed, grazed during the daytime. So this is daytime grazing, so that's outside between the morning and afternoon milking, either with access to the TMR, which is this here, or daytime grazing, so that's out between the morning and the afternoon without access to the TMR. So we can see that in the control treatment here, the cows gave about 39 kilograms of milk, fat was about 37, and they gained quite a bit of live weight change over that. Allowing the cows out to graze during the daytime with access to the TMR, then they ate a small amount of grass. They didn't eat a tremendous amount, but the milk yield was very similar to the inside cows, so we could get them outside during the daytime and maintain milk yield. However, when we didn't have access to the TMR, then milk yield was lower, as were milk fat levels, and weight change came down. So grazing them during the daytime without access to the TMR significantly reduced milk yield and reduced weight change. The other thing that we were interested in was the methane output, and you can see the grazing cow there with a backpack on, and you can see the cow in the feed bin at the top has got a little tube over her nasal area, over her mouth area, and every time she belches, that takes a gas sample, and from that, using a little bit of calculations, we can work out the methane output. And you can see that the interesting comparison is these two here, because we had a similar milk yield, and the only difference was really this intake of grass, and we had a significant reduction in methane production grams per kilogram milk. And we think that's possibly to do with some of the fatty acids or even the sugar that's present in grass. So moving on to the final topic, which is mineral feeding. And we've had a series of studies looking at overall mineral feeding. Copper we've been focusing on particularly, and we currently have a study looking at cobalt and vitamin B12. But the first study that we did for DairyCo was to look at winter feeding levels. And this is some of the selected minerals that I've chosen here. And this is a percentage of requirement. So to put them all on the same scale, a percentage of requirement, where 100 is what the textbook would say that the animal should receive. And then we calculated, we went on to farms, we took samples of the forage, the concentrates, their drinking water, supplements, etc., and calculated how much they were actually feeding. And you can see that almost without exception, every mineral was being overfed, particularly copper here, and this is the one that we're focusing on. And copper was being fed considerably higher than what is recommended, but also higher than what the UK feed industry. And in fact, around about just over 10% of our farms are feeding illegal amounts of copper. We also looked at organic herds because we wanted to determine whether they were any different. And the organic herds that we sampled, well, it's a smaller sample size, only 10 organic herds, they had a very similar profile. So this overfeeding over the winter time of minerals seems to be pretty common regardless of feeding system. Very briefly, just to finish off, want to focus on phosphorus, and it looks to be the one that's least overfed, but it's still being about 25% above requirements. And the interest in phosphorus is that many commentators would say that we're going to run out of phosphorus before we run out of fossil fuels, and the cost of phosphorus has been increasing over the last several years or so. Traditionally, it was fed at high levels, around about 7 grams per kilogram dry matter, in the belief that it benefited intake, milk production and reproduction, but there's considerable issues in relating to the cost and the environmental impact. And just to finish off in terms of research studies, this was one that was recently done at Hillsborough in Northern Ireland, where they were looking at 2 different levels. 4.4 grams per kilogram dry matter was what we recorded to be what was being fed in the UK, and 3.6 is round about the recommended levels. So they fed roughly the recommended levels and the typical UK feeding levels here. They did that over 4 years, so it's a long-term study, involved a lot of animals, but you needed to do that with something like phosphorus, where you've got large body depots and short-term studies aren't really as important. But you can see over the 4 years that milk yield was similar, as was milk fat, milk protein, Bone strength, as indicated by depth of rib, was similar, as was calving interval. The only difference was the fecal phosphorus output, which they calculated to be somewhere in the region of around about 10 kilograms of phosphorus per hectare per year that could be saved without any detrimental effect in terms of milk or performance. And that's important in terms of cost, but also from an environmental aspect, because that 10 kilograms is the maximum that we can apply on grassland-only farms. So to finish off, and we've covered quite a bit in the last sort of 20-25 minutes or so, we are facing an increasing demand for dairy products. It may not feel like that just now, but that is certainly the long-term trend and what's being forecast. And that will result in a greater demand for a lot of feeds that we have traditionally considered as being dairy cow feeds in the UK. A lot of the countries that are looking to increase milk production, and I've been out to Sri Lanka and to China in the last 6 months or so, they're looking at doing that not from a grazing or forage point of view, but from purchasing supplements. So there may be a reduction in traditional feeds, introduction of new feeds, also demand for biofuels, also demand for human food use will all impact, but inevitably it'll be the market price that will dictate. We're looking at lots of technology and improvements in rumen function and monitoring, which will assist us in terms of feeding cows and supplementation. Advances in plant breeding for nutritive value, I think, have to become more important rather than just for yield. So things such as the fatty acid content and in terms of aspects in relation to the rumen degradability that we've been speaking about. And we shouldn't take our eye off the fact that we've got to, nutrition isn't just about milk production. We have to look at cow health and welfare. Fertility is key, as is the environment and milk quality. And that's going to require more accurate nutrient requirements and more accurate supply.